Welcome back. We just saw how to multiply a matrix to a column. Remember, matrix is on the left, column on the right. You replace every row by its transpose and multiply to the column. You go across, straight down, across, straight down, across, straight down, and you get, for each row, you get a number and you stack it one below the other. Row 1 gets you the first number, row 2 gets you the second number, row 3 gets you the third number, and so on. Now we are ready to multiply two matrices. Consider the matrix here A. As you can see, it has 3 rows and 4 columns. Consider the matrix B. As you can see, it has 4 rows and 5 columns. Take note of their respective sizes. A is 3 by 4, B is 4 by 5. This is important. A is 3 by 4, B is 4 by 5. You want these numbers to match, the middle numbers. What do the middle numbers represent? This 4 represents the number of columns of A. This 4 represents the number of rows of B. So the number of columns of the first matrix must match number of rows of the second matrix. We may then multiply. But if the number of rows of the first matrix, if the number of columns of the first matrix does not agree with the number of rows of the second matrix, then we may not multiply. So make sure columns of the first, rows of the second match. Best way to remember, write the matrices down, make sure the middle numbers match. When that happens, when the middle numbers match, the result will be end numbers. The result matrix will be 3 by 5. Okay? So, how do we multiply this? Remember, we know how to multiply a matrix on the left and a column on the right, only one column. So, why not think of this matrix B as a sequence of columns? You have 5 columns. I can multiply A to each one separately. All right. When I multiply this matrix to this column, I'll get a row. I'll get a column, is different column. Multiply this matrix to this, I'll get another column. So I get to stack the columns together. Okay. So second matrix, you separate them into columns. First matrix, you leave it as is. Okay. So let's, with all this behind us, now let's actually see how it looks like. I'm focused on the first column alone of matrix B. I'm ignoring everything else. Focus only on the first column. How do I multiply this matrix to this? Remember, go across, straight down. 3 times negative 2 plus negative 2 times 3 plus 4 times 0 plus 7 times 4. That's row 1. 2 times negative 2 plus negative 1 times negative 2, negative 1 times 3, plus 5 times 0 plus 2 times 4. Now the third row, notice I'm only focused on this column, ignore everybody else. 3 times negative 2 plus 4 times 3 plus 9 times 0 plus 0 times 4. So that's with row 3. Simplifying all of this, assuming my arithmetic is correct, Matrix A with column 1 gives me this column. Now column 2. So I'm focused now on column 2. Ignore everybody else, every other column. Only focus on column 2. Matrix A with column 2. 3 times 3 plus negative 2 times negative 1 plus 4 times 2 plus 7 times 8. That was row 1. Row 2, 2 times 3 plus negative 1 times negative 1 plus 5 times 2 plus 2 times 8. That was using row 2. Now row 3. 3 times 3 plus 4 times negative 1 plus 9 times 2 plus 0 times 8. Okay, that was row 3. Assuming my arithmetic is correct, this is the result using column 2. Now column 3, same story. Now I'm focused on column 3. Ignore all the other columns. Go across, go down. 3 times 0 plus negative 2 times 2 plus 4 times 1 plus 7 times 4. That was row 1. Row 2. 2 times 0 plus negative 1 times 2 plus 5 times 1 plus 2 times 4. That was using row 2. Now row 3. 3 times 0 plus 4 times 2 plus 9 times 1 plus 0 times 4. So notice how we go across, go down, across, go down. So we handled column 3, assuming my arithmetic is correct. That's my answer for column 3. Likewise, column 4. At this point, you know how to do this. Ignore all the other columns. Just focus on this column. Go across with A, down with the column. Across with the A, down with the column. Across with the A, down with the column. So go across and down, and that's the result with column 4. Lastly, with column 5. Okay, across, down, across, down, across, down. That's with the column 5. So for each column, I got an answer, a new column. Okay, put all the columns together. This was with column 1. This was column 2. This was from column 3. This was from column 4. This was from column 5. If you don't believe me, go back and check. 16, 1, 6. That was column 1. 75, 33, 23. That's column 2. Column 3, 28, 11, 17. Where is column 3? There, 28, 11, 17. Column 4, 30, 45. Column 4. Column 5, 29, 17, 28. Okay, assuming of course my arithmetic is correct. I hope you understand how to multiply matrices. Go across, go down. So focus on one column at a time. Across, down, across, down, across, down. That's one column. Second column. Across, down, across, down, across, down. Second column. Third column, and so on. Okay, it's across, down. In notation, symbolic notation, formulaic way, mind you, matrix multiplication is highly programmable precisely because it is just algorithmic. You have matrix A, size m by n. You have matrix B, size n by r. The n's have to match. The result will be m by r. Okay, let's check that with our example. 3 by 4, 4 by 5. Result is 3 by 5. 5, because there are 5 columns to begin with. Sorry, and 3 because there are 3 rows from A, 5 columns from B. Okay, so you have the result is number of rows from A and number of columns from B. The middle numbers have to match. How do we write this programmatically? How can you say, what can you say about CIK in terms of AIJ and BJK? CIK, now this is something that takes getting used to, takes some time. CIK is summation j going from 1 to n of AIJ times BJK. Notice the j's have to match. AIJ times BJK. What is that I? That is the ith row location. What is that K? That's the kth column location of the product matrix. CIK lives in ith row, kth column. How do you find CIK? Using this formula. AIJ times BJK, summation j going from 1 to n, AIJ times BJK. Okay, so j runs through the entire sequence 1 through n. A and B, they represent the entries of A, matrix A and matrix B respectively. What is a linear system? If you remember, linear system is a system of equations. Each of these equations is linear. That is, power of x is just 1. In this case, you have m equations in n variables equals m numbers. Well, we may write this in matrix notation. Just write the coefficients ai's followed by a column of xi's equals the right hand side column. Why can we write it like this? You see, now you know how to multiply a matrix to a column. Go across, straight down. A11 x1 plus A12 x2 all the way A1n xm. Isn't that line? Likewise, second line. A21 x1 plus A22 x2 all the way to A2n xm. That's the second line. Okay, equals B1, B2 respectively. So this entire system may be written as one equation among matrices. Okay, A is the coefficient matrix, X is the variable matrix, B is the right hand side result matrix. Okay, so the linear system may be written as coefficient matrix times the variable matrix. Variable matrix, notice, is a column, equals the right hand side result matrix, which is also a column. Okay, matrix A is called the coefficient matrix of the linear system. Okay, let's continue in our next video.